I just got the notification too. Hi, everyone. I hope you are excited to join us. We are the Girl Scout Spirit of Nebraska Beyond Our World Astronomy Club. And we are getting together here to not only teach each other, but to get you interested about astronomy too. So we're going to give it a couple minutes just for people to get logged on before we start our presentation. There are a couple people that I'd like to introduce. Tina, up in our I think, where is she at? She's right below me on my screen. She leads our, or helps to lead our Chadron-based astronomy club. Krista, she is our amateur astronomer, and she helps to lead our Omaha astronomy club. And then I work with girls in Lakeview in North Platte, and I work with our girls here to host our astronomy club. We also have one in Lincoln. All right. So we're going to start here. I'm going to share my screen and we are going to begin our presentation. So as I said before, welcome to our Beyond Our World Astronomy Club, brought to you by Girl Scouts Spirit of Nebraska. So what we're going to do today is we're going to get to know the moon and learn about its phases. We're going to take you on a tour of some meteors. You're going to meet our solar system, specifically the planets in our solar system. We're going to talk about the James Webb Space Telescope. We'll talk about our Beyond Our World newsletter that we send out every month with some breaking news. And then we are going to introduce Krista, who is our amateur astronomer, and she's going to show us some very fun and exciting things. So, the moon and its phases. So our moon is the only natural, it's the largest natural satellite and the only natural satellite that Earth has. We're going to talk a little bit about the phases. I'm going to play a video for you, and I hope you can hear it.
Hi, my name is Emily Morgan, and I'm the author of Next Time You See the Moon from NSTA Kids. And I'd like to share a simple activity with you that can help you understand why the moon looks different at different times throughout the month. Why sometimes it looks like a banana, and other times it looks like half of a circle, and other times it looks like a big round ball. Well, to do this activity, you only need 4 simple things. You need a lamp with the shade removed, a white foam ball, a pencil, and a dark room. The darker the room, the better. Now in this model, the lamp is going to represent the sun, and of course the white foam ball is going to represent the moon, and your head is going to represent the Earth. So let me show you how this works. We know that the moon orbits the Earth. So in this model, I'm going to get the moon, the foam ball, to orbit the Earth, my head. Notice that no matter where the moon is in its orbit, half of it is always lit up by the sun. But when the moon is in this position, I can't see any of the lighted side of the moon from Earth, my head. From this angle, you can see what I am seeing from Earth. We call this new moon, When it's new moon, we look up at the sky and we can't see the moon. It's there, but the side that's reflecting sunlight is away from us. Now, as I slowly make the moon orbit to my left, I can begin to see a tiny sliver of that lighted side. We call that a crescent moon. As the moon keeps orbiting, we can see more and more of that lighted side. We see half of the lighted half, which is a quarter moon. In this case, a first quarter moon. As we keep orbiting, we see almost the whole lighted side. We call that a gibbous moon. Then, when we can see the entire lighted half of the moon, that's a full moon. As the moon continues in its orbit, we begin to see less and less of that lighted side. We're back to a gibbous moon, but this time the light is on the opposite side. Then another quarter moon, last quarter moon to be exact. Another crescent, and finally back to new moon. And the cycle begins again. So why does the moon appear in different shapes throughout the month? Because of its orbit. The shape or phase of the moon depends on where it is in its orbit around Earth. It takes about a month for the moon to orbit the Earth. So when you look up at the moon today, know that you'll see that same phase again about a month from now. Thank you for watching, and I hope you give this activity a try. And I hope that you have a sense of wonder next time you see the moon. For a full
All right, so that
description
gives you somewhat of an idea about how the phases of the moon are created. There are some fun facts I'd like to share with you about the moon. So, for example, did you know that the dark side of the moon is a myth? As you could see, every side of the moon actually has sunlight on it at some point in its rotation around our Earth. And you could see that while she was spinning around. Did you know that the rise and fall of the tides is caused by the moon? There are two bulges in the Earth due to the gravitational pull that the moon exerts, one on one side facing the moon and the other on the opposite side that faces away from the moon. The bulges move around the oceans as the Earth rotates, causing high and low tides. Did you also know that the moon is drifting away from the Earth? It drifts away approximately 3.8 centimeters from our planet every year. It is estimated that it will continue to do so for about 50 billion years. So don't worry, we won't lose our moon in our lifetimes. So we're going to show you an example. Oops. So this activity we actually do at our astronomy clubs. We do a lot of experiments and they're a lot of fun. So here you can see the girls in our astronomy club practicing with the foam ball on the pencil using their head as the Earth. Do we have any questions about the moon? All right. We're going to move on.
My name is Cadence Fisher. I'm a junior Girl Scout in Troop 10306 in Chadron. A meteor shower is an astronomical event in which hundreds or thousands of dust-sized meteoroids enter the Earth's atmosphere and almost immediately burn up, creating a short-lived glowing streak in the night sky. These particles form a lingering trail called a meteor stream behind a comet as it passes around the sun. The key to seeing a meteor shower is to go to a dark area such as suburbs or countryside. Prepare to sit outside for a few hours because it takes around 30 minutes for your eyes to adjust to the darkness. The longer you wait outside, the more meteors you will see. The biggest meteor shower took place on January 30th, 1868, over Poland, with impacts occurring across the region near the town of Poltusk. Around December 14th, I watched the Geminids. Did I say that right?
Yep.
Geminids meteor shower. The meteors were very quick to disappear, but it was interesting to see how often they were present, and at times I would see at times I wouldn't see any for a while, and at others I saw 5 at the time. The parent body of this meteor shower is thought to be the rock comet called Phaethon, I think.
Yeah, Phaethon.
Phaethon. The next shower, called Lyrids, will occur from April 16th through April 30th, but peak on the 21st through 22nd. This shower will be medium strength. The meteors will lack persistent trains, but can produce fireballs. It will be best viewed in the northern hemisphere before dawn. It's named after the constellation Lyra. It's one of the oldest observed, as long as 2,500 years ago. It's created by the debris from the comet Thatcher, which takes 415 years to orbit the sun. The comet is expected to be visible from Earth in the year 2276. Yeah. My favorite part about Astronomy Club was when we did the black hole.
Tell them about it.
We took a hula hoop with black fabric and wrapped it around there, and we put marbles on to see them go around and meet in the center. Yeah.
She did a really good job. And that's a little bit about meteors. So here is a crater impact experiment that we do during our astronomy clubs. This one can get a little messy, but it's a lot of fun. So what you can do is take a cake pan, preferably one that is tinfoil, like aluminum, layer it with flour and cake sprinkles. And then you can put cocoa on top, and you need about 2 to 3 small rocks. And what you do is you stand up high and you drop them into the flour to see how the impact of a meteor affects the surface. Krista, did you want to add anything with this?
You can change it up by using different size rocks. You can change it up by going and throwing it into your mixture at angles. If you're really daring and you're outside, you could use mechanical forces to help you project that rock or a little bit further.
All right, well, we're going to show you a video of what happens when you do this experiment, and the video is in slow motion. So let's see what happens.
All right.
Hannah, Mom.
Krista, would you like to tell us what happened there?
I guess I certainly can. So this was a slow motion. They are dropping a weight into that pan, which has a layer of flour or something similar, and then a different color on top. So we use cocoa powder, And you could see as the weight hits into our surface that there's this explosion of material moving out of the way. And they make these little lines called rays. And I'm sure if you look up at the moon, many of you will see those rays from impacts on the moon.
That's a really fun experiment that you can do at home, that we do with our astronomy clubs as well, just to kind of show you what things look like and how things operate. So Jeremy wants to know, why does the moon move away? I am going to defer to our amateur astronomer.
That's a great question that gets asked a lot, actually. We have a unique moon. It is actually too large for Earth to hold in its gravity at a constant distance. Common theory and taught about is how the moon was formed. And it was actually a big, now we weren't around, of course, but most people believe it was a big chunk of Earth that was ripped away. And that big chunk is just too big for Earth's gravity to hold in. So it's just a little bit, because if the Earth and moon were playing a tug of war, right now it's close to balance, but not quite. Earth can't hold quite enough to keep it in balance. If we look at some of the other moons around other planets, our neighboring comparison would be Mars. Mars has 2 moons, but they're really small, rocky asteroid-like moons that are like the size of our moon, are really around supergiant planets like Jupiter, Saturn, have a larger gravity.
Thank you for that answer. It was actually Leah who was using her dad, Jeremy's Facebook. So thank you for that question, Leah. That's a really good question. And it's a really interesting thing to think about. We have the 5th largest moon in our solar system, and it is very unique. I don't know about you, but I love the moon. It's pretty awesome.
All right.
All right. Were there any other questions? And if you're just now joining us on Facebook, my name is Kat, and I'm a program specialist here in North Platte for Girl Scouts Spirit of Nebraska. And one of the things that I help with is the Beyond Our World Astronomy Club. And we just wanted to share with you some of the things we do with our clubs. So if you have questions, please put them in the comments and we will get to them as soon as we can. All right, so now we're going to go into our solar system. Our solar system is, where we live. The largest body in our solar system is the sun. We have 8 planets, some dwarf planets, an asteroid belt, and comets, among other things. What we're going to do right now is take you on a tour so that you can meet all of the planets. Are you all ready to meet the planets? Yeah? All right. First up is Mercury, presented by Hannah.
Hey everyone, my name is Hannah, and I am the Girl Scout leader of the Lakeview Astronomy Club. And sorry if you hear my dog, she's very loud. So each girl was assigned a planet to do research and share it with you. And so I'm excited to start off with Mercury. So Mercury was formed about 4.5 billion years ago. Mercury gets its name from the Roman god, which is known as the swiftest god, and which is also the planet's nickname, called the Swift Planet. So Mercury is the smallest planet, not including Pluto, which is a dwarf. It isn't the hottest, considering it's the closest to the sun. And so the surface looks a lot like the moon, which are Earth moon. And the largest crater on Mercury is 1,550 kilometers, or 963 miles, called Calorus Basis. The distance from the sun is 57.91 million kilometers, and it completes an orbit around the sun in 88 Earth days. So important events of Mercury is Mercury was thought to be two different objects in the sky, the morning star and the evening star. The first recorded observations by people were the ancient Assyrian astronomers in the 14th century BC. And so that's a little crash course of Mercury.
Thank you so much, Hannah. All right, our next planet is Venus, presented by Bry.
Venus is one of the hottest planets in our solar system. Venus has a thick atmosphere. Its temperature, heat, and makes Venus very hot. The time on Venus. A day on Venus lasts 243 Earth days. A year on Venus lasts 225 Earth days. Venus does not have any moons. While Venus is nearly the sun's planet of the solar system. In fact, Venus can appear so bright that above an Air Canada flight in January 2011. Temperatures there can reach up to 870 degrees Fahrenheit, 470 degrees Celsius. The surface is not hot enough to melt lead due to its runaway greenhouse atmosphere. A day on Venus lasts 233 Earth days. That's how long it takes Venus to make one rotation, while a year on Venus, it returns period around the sun. It's shorter than just 224.7 Earth days. There are more volcanoes on Venus than on any other planet in the solar system. As the second biggest neutron orbit in Earth night sky, other than the moon, Venus can cast shallow and can be on rare atmospheres available to the naked eye in broad daylight. Distance from the sun, 67.25 million miles. Length of day, 116 days, 18 hours, and 0 minutes. Here's a picture of the solar system, and Venus is the second one from the sun, so right there. This is inside of Venus, the outer layer, middle layer, and then center.
Good job, Bri. Thank you so much. All right. Our next planet is Earth, presented by Lena.
We live on Earth, the only planet known to have life. The Earth orbits the Sun and spins on an axis. Earth is the third planet from the Sun. It's in the Goldilocks zone. Just like the story of Goldilocks and the Three Bears. The path of the Earth isn't too hot and isn't too cold. Its temperature is just right to support life. The structure of the Earth is made up of 4 main parts. The inner core is solid, the outer core is liquid. The mantle is solid and floats on the outer core. The crust is the outside layer. It is made of solid rock. The crust and the upper mantle are broken up into tectonic plates. These plates move and create mountains, volcanoes, and earthquakes. About 71% of Earth's surface is covered in water. The oceans contain about 96.5% of the Earth's water. 2.5% of the water is drinkable, but we only have access to 1%. There is more fresh water stored in the ground than found in rivers and lakes. Most of the fresh water is found in glaciers and ice caps.
That was a great presentation, Lena. Thank you so much. Okay. All right, our next planet is Mars. Give me 1 second. Minor technical difficulties.
Why did people name him Mars? Mars is named after the ancient Roman god of war and the Greek god of war, Ares. They referred to this planet this way because its deep red color resembled blood. Significant features. On the common surface of Mars are dark slope streaks, sand dunes, fretted terrain, and glaciers. On Mars, the moons don't look like moons. When the planet is shining its brightest, then it resembles Venus as seen on Earth. Distance from the Sun and Earth. The distance from the Sun to Mars is 143.46 million miles away. That is a lot of miles. The distance from Earth to to Mars is 100.77 miles away. Important events. On August 6, 1672, scientists observed its polar ice cap. On April 12, 1963, scientists investigated the air on Mars. On November 14, 1971, Mariner 9 visits Mars. Fun facts. Mars was discovered in 1610. It has 2 moons. Only 18 missions to Mars have been successful. The name of the rovers that have gone to Mars were Sojourner, Spirit, Opportunity, and Curiosity. Curiosity is still working on Mars.
Thank you so much, Leighton, for that. That was a great job. Our next planet is Jupiter, presented by Leila.
My name is Leila, and I'm going to be talking to you about the planet Jupiter. Jupiter is the largest the largest solar planet in the solar system, and it is the 5th planet from the Sun. It is more than 300 times more massive than the Earth and is more than 2 times as massive than all the other planets combined. That's huge. Jupiter's surface is violent with massive hurricanes, like hurricane-like storms, winds, thunder, and lightning. The storm on Jupiter is called the Great Red Spot. It's 3 times the size of Earth. The Great Red Spot has been storming for hundreds of years. The energy powering Jupiter's storm isn't from the Sun, like Earth storms, but from radiation generated by Jupiter itself. No one can live on Jupiter. Jupiter is wildly different from Earth. First off, there's no place to stand. The surface is gas. Second, Jupiter is 300 times the size of the Earth. That's at least 79 moons. It has at least 79 moons versus Earth's 1 moon. Also, Jupiter has 300-year-old storm that could swallow up Earth without even noticing it. I'm glad we don't have any storms like that. Jupiter is the 3rd brightest subject in the sky. Galileo first discovered Jupiter's 4 largest moons in 1610, and others claim to have discovered the Great Red Spot not long after. In 1973, the space probe Pioneer 10 flew by Jupiter to provide the first close-up pictures of the planet. The Pioneer's probes were followed by Voyager 1 and 2, which gave us the first close-up shots of Jupiter's moon. Since there have been more flybys of Jupiter, only one spacecraft to orbit Jupiter was Galileo in 1995. That's Jupiter.
Thank you so much, Leila. Our next planet is Saturn. Thank you so much, Ange, for putting the presentation together. Here we go.
So I will be speaking for Ange. So Saturn is the 6th planet in our solar system and the 2nd largest. It is a gas giant whose average radius is about 9 times that of Earth's. Despite its 1/8 average in density compared to Earth, Saturn is 95 times more massive. Saturn was named after the Roman god of wealth and agriculture. Even the day of the week, Saturday, is called Saturn's Day. So Saturn's interior is more likely composed of an iron, nickel, and rock core surrounded by a layer of metallic hydrogen and an intermediate layer of liquid hydrogen and liquid helium, to have its outermost layer to be gaseous. Sorry. Hold on. Saturn has 83 known moons, in which 53 have formal names. There are determined to be dozens to hundreds of moonlets with diameters of 40 to 500 meters in Saturn's rings. They are not considered true moons. Titan, the largest moon, comprises more than 90% of mass in orbit around Saturn, including the rings. Titan is the only satellite in the solar system with a stable atmosphere and hydrocarbon lakes from complex chemistry. Many other moons are small, 34 being less than 10 kilometers in diameter, and others being 14 between 10 and 50 kilometers. Saturn rings and how far from Earth? The most noticeable part of the planet is the system of the planetary rings, and they are made mostly of water, ice, and traces amount of thallium and imprints of carbon. The rings extend from 6,630 to 120,700 kilometers, 4,120 to 75,000 miles, out from Saturn's equator and average approximately 200 meters, which is 66 feet, in thickness. The particles in the rings themselves are average up to 10 meters. While other gas giants have ring system, Saturn is the largest and most seeable. Saturn is approximately 1.4 billion kilometers away from Earth. It takes approximately 29.4571 thousand Earth years, or 10,759.22 Earth days, or 24,491.07 Saturn solar days for Saturn to complete a full rotation around the sun. And then the next slide is the surface area and volume. I will probably most likely mess up all of this, so I'm probably not going to read it.
That's perfectly fine. So Saturn's surface area is about, what would that be? Basically take 1.65 and put 10 to the 10th power number of zeros behind it. It's a lot. It's huge. It's giant. So much bigger than ours, than Earth. Our next planet is Uranus, and that is going to be presented by Becca.
Hi.
Hi, Becca.
I had technical difficulties. I lost my mouse.
That's okay. Tell us all about Uranus.
So, Uranus was named after an ancient Greek god, the god of the sky. Uranus is the only planet to be named after a Greek god instead of a Roman god. Uranus is the 7th planet from the Sun at a distance of about 1.8 billion miles. Uranus is known as the sideways planet because it has a unique tilt, rotating at a nearly 90-degree angle from the plane of its orbit, making it appear to spin on its side, and rotates backwards east to west. Discovered in 1781 by William Herschel, it was the first planet found using a telescope. Uranus is a ice giant planet, the coldest in the solar system, and nearly 4 times larger than Earth. So if Earth were a large apple, Uranus would be the size of a basketball. Uranus has 27 known moons, most of which are named after literary characters from William Shakespeare and Alexander Pope. Uranus is a ringed planet with 13 known rings. The inner rings are narrow and dark, and the outer rings are brightly colored. Voyager 2 is the only spacecraft to fly by Uranus. No other spacecraft has orbited the planet to study it up close. The element uranium was named after Uranus. The methane in Uranus's atmosphere is what makes it blue. One day on Uranus is about 17 Earth hours, and 1 year is about 84 Earth years.
Awesome. Thank you so much, Becca. All right, our next planet is Neptune.
The planet that I am presenting is Neptune. Neptune was named from the Roman god of the sea because it is blue. Neptune is the eighth and the farthest planet from the sun. Neptune's atmosphere gives it a blue color, which is fitting with it being named after the Roman god of the seas. Neptune is an ice giant planet. This means it has a gas surface like the gas giant planet, but it has an interior composed mostly of ice and rock. Neptune is slightly smaller than its sister planet Uranus, making it the fourth largest planet. However, Neptune is a little bit larger in mass than Uranus, making it the third largest planet by mass. Neptune atmosphere, I can't say right, is mostly made up of hydrogen, which adds smaller amount of helium. The surface of Neptune swirls with huge storms and powerful winds. One large storm photographed by Voyager 2 when it passed by Neptune in 1989. It was called the Great Dark Spot. The storm was as big as the size of the Earth. Neptune has 14 known moons. The largest of Neptune's moon is Triton. Neptune also has smaller ring system similar to Saturn, but not nearly as large or as visible. Since Neptune is a gas giant planet, there is no rocky surface to walk around on like Earth. Also, Neptune is far away from the sun that, unlike Earth, it gets most of its energy from its inner core rather than from the sun. Neptune is much bigger than the Earth, even though much of Neptune is gas. Its mass is 17 times of the Earth. Neptune is an average distance of 2.8 billion miles from the sun. How far is Neptune from the Earth? The distance from one planet to another is constantly shifting because both bodies are moving through space. When Neptune's and Earth lines up on the same side of the sun at their closest, they are only 2.7 billion miles, 4.3 billion kilometers apart.
Thank you so much, Destiny. That was great information about Neptune. All right, our next planet is Pluto, presented by Steffi.
Pluto. The surface of Pluto is comprised of a mixture of frozen hydrogen, methane, and carbon monoxide ices. The surface temperature of Pluto can reach up to negative 400 degrees Fahrenheit. On Pluto, there are mountains that can reach 6,500 to 9,800 feet tall and have valleys long as 370 miles. Pluto's atmosphere expands as it gets closer to the sun and then collapses as it moves away. Gases that have been detected in Pluto's atmosphere include molecular nitrogen, but molecules of methane and carbon monoxide have also been detected. When Pluto is away from the sun, most of Pluto's atmosphere freezes and falls as snow to the surface. Pluto's moons. So far, we have discovered 5 moons orbiting Pluto: Charon, Sphinx, Nix, and Kerberos, and Hydra. Charon being the closest to Pluto and Hydra being the furthest. Charon has been proven to be geologically active. Fun facts about Pluto. Did you know that Pluto hasn't made a full orbit around the sun since we discovered it? It is estimated that Pluto will complete its orbit in March 23rd, 2178. It takes Pluto 248 Earth years to make a full orbit around the sun. Charon is about the size of Pluto, making it more of a double planet system.
Thank you so much, Steffi. Do we have any questions about our planets? There's a little bit of a lag going from what I say to Facebook Live. So we'll just give it a couple minutes and see if anyone has any questions before we move on to our next topic.
Do you want me to answer some of the questions that came in from our own group?
Yeah, sure.
Okay. So I saw one early on about moons. And so someone
I can barely hear you, Krista.
Okay, is that better?
Oh, much better. Thank you.
Okay. I keep having to switch headsets. So it came early on how many moons there are in our solar system. Destiny. And I know that there's over 100. NASA, on most of their websites, states over 200. But if you include, like Pluto, we learned about the 5 moons of Pluto. Our dwarf planets, there is like 200 recognized moons in our own solar system. There was another question not too long ago from, let's see, how to pronounce Uranus or Uranus. And that was our Nebraska junior. And in the United States, both pronunciations are acceptable, both Uranus and Uranus. Most people in middle school teachers, they say Uranus because of giggles. If you look internationally, it is worldwide, the proper pronunciation would be Uranus.
So Leah asked about life on other planets, and your mic is breaking up just a little bit, just to let you know.
So is that one you want me to answer? Okay. so far, we have not found life on other planets. It's not a definite. We are searching. There are lots of potential places for life within our solar system still. But most people, when they think of finding life, they're thinking of like the movies, Little Green Men. And that's not what an astrobiologist, astronomer who's looking for life outside of our solar system, that's not necessarily what they're looking for. They would love to find bacteria and mold. Are like the first organisms of life, and that's what they would be looking for. Could potentially still find something on Mars, some of the Saturn, but as of yet, we have not proven that there is living organisms.
Awesome. Thank you so much. All right. Let's see here. All right. So the next topic we're going to talk about is the James Webb Space Telescope. And this is going to be launched this year. And Kate is going to tell you all about it.
Hello everyone, my name is Kate Lembry and I'm a part of the Omaha-based Beyond Our World Astronomy Club. I hope everyone's having a great Sunday and enjoying the meeting so far. Out in Omaha, our main focus for this month is launches that will be happening in 2021. So I'm going to take a little bit of time to tell you guys about the one I'm most excited about, which is the James Webb Telescope. So I'm going to go ahead and share my screen with you guys. You can see what I'm talking about. Okay, so the James Webb Telescope will be launching October 31st in 2021. So what is the James Webb Telescope? It's called the JWST. It is noted to be a replacement for Hubble, and it's about 100 times more powerful than Hubble will be. It will orbit above Earth from 100 million miles, and it is so large in size that it will unfold itself origami style while in space. So it'll be like a real life transformer when it launches on the 31st. So the goals of the JWST is to search for the first galaxies formed by the Big Bang about 13.5 billion years ago. It will research the evolution of galaxies. It will observe the formation of stars and measure physical and chemical properties of planetary systems. So it will be able to see different solar systems that are farther away from us that we've never been able to kind of witness and explore before, and we'll be able to see what those planets that are revolving around those stars are made out of, and if they have the ability to support life, and so on. So something important about the James Webb Telescope that makes it different is the visible versus infrared light. So as you can see in the picture I have up, it shows the difference between visible and infrared light. And so if you look at the infrared side, you can see that there's a lot more stars visible than on the visible side, which kind of sounds a little interesting. But the infrared side basically is blocking out all of the dust and particles that are flying around space and blocking our view. So when you're using visible light, it's being clouded by all this space dust that's flying around. But the infrared side, it allows it to see through all of those different space dust particles and stuff so that you can see all of the different stars that are out there. So the JWST will be equipped with infrared cameras, the near-infrared camera, the near-infrared spectrograph, a mid-infrared instrument, and a fine guidance sensor / near-infrared imager. It also will have a sun shield. This sun shield will have 5 layers, which will allow the instruments inside of it to stay cool. Because there are 5 different layers, each layer in succession is going to be cooler than the last one, and the vacuum between the 2 layers will act as an insulator in order to keep all of the important equipment and instruments inside of the telescope nice and cool so that they don't have any issues and they can go ahead and run as normal. So each layer of this sun shield is made out of Kapton, and it is coated in aluminum so that it stays nice and cool, and it has the ability to kind of protect itself from the sun. So the two layers that will be closest to the sun will be also coated in silicon to act as a protectant between the two. And something really, really interesting about these layers is they will be 0.001 inches thick, which is thinner than a sheet of paper. So the whole sun shield will be very, very thin once it's finished. One of the most important parts of the James Webb Telescope is the mirror that's on it. That's the big gold thing that you see in the corner up here. The Hubble primary mirror is shown in the bottom left. And you can see just how much bigger the JWST primary mirror will be compared to Hubble. And then next to the Hubble mirror, you can see the size of an average man. So each of the mirror segments are made out of beryllium, and they weigh 46 pounds each. So that's about the weight of a cinder block. There are 18 different segments of the mirror, and they will fold up and unfold when the telescope is launched into space. And there's a gold coating that will be added to each segment. And some might think, why are we sending gold up into space? How does that improve the mirror, how it works? So gold has properties that will improve the refraction of infrared light, allowing the cameras and all of the fun technology that's on the James Webb Telescope to pick up maybe a different star or planet, and it just allows it to be able to read better in like space. So each segment, so there are 18 different segments, and each of those segments takes one golf ball size amount of gold in order to cover it. And then the bottom picture I have on this slide is some NASA workers working on one of the beryllium mirrors. So that is about the size it is, and that's obviously before it's been covered in the gold plating and polished up. So that just shows you the beryllium mirror. And if you're interested in learning more about the James Webb Telescope, I have some links up on screen for you guys so that you can go ahead and learn more. They're in order of what I talked about. So the first link is just some general information. The second link is about infrared, if you have more questions about that. The third link is the sun shield, so if you have any questions about that. And then the last one is the James Webb mirror. So if you have any questions about how it opens or anything like that, you can go ahead and look it up. I really want to thank you guys for joining our meeting and allowing me to go ahead and be a part of your guys' Sunday. I hope you guys enjoy the rest of the meeting and you've had a great time thus far. And I will go ahead and pass it on to my next presenter. Thanks, guys.
Thank you so much, Kate. So do we have any questions about this space telescope? Kate did do a very, very good job. All right, so we're going to move on. One of the things that we do with our astronomy club is every month we send out a newsletter that talks about the latest and greatest in space news, plus gives you some tips about, for example, how to measure distance in the sky, because when you measure distance, you use degrees and not inches or anything like that. So we include information like that in our newsletters. We also include a list of that month's astronomical events. So if there's going to be a meteor shower, we tell you what date it's going to happen on. So I do see that there is a question from Ashley. What is the purpose of the James Webb Telescope? So the purpose of that telescope is to try to find the galaxies that were created right after the Big Bang, when the whole universe was created. So that's what it's trying to do. It's 100 times more powerful than the Hubble telescope. So if you saw like all of the pictures that we've shown today, maybe not all of them, but a good portion of them came from the Hubble telescope. And you can see how detailed those images were. This other telescope is going to show us so much more detail, and it'll filter out things like space dust so that we can see through the dust and beyond it. I hope that answers your question. It's so that we can, find more things. It's really going to be very neat. So we have a special guest from NASA News, from the Beyond Our World Astronomy Club NASA News. Isis is here to tell you some breaking news.
Breaking news. Orphan planet found near Earth. NASA has found a rogue orphan alien planet only 100 light years away from Earth. The planet is scientifically known as CFB ISIR 2149. There is no parent star found near this planet, so the only light that can be seen is by infrared light. But scientists have found it easier to research this planet because of no overwhelming glare from a parent star or sun. Currently, the thought of a rogue alien planet is not rare, but also not common. There have been several others cited in our galaxy. Scientists believe that this planet was kicked out of its solar system and has been wandering since. But if this planet can be kicked out of its solar system, could Earth? What could happen to any of our planets? Will Mars be gone before we could reach it? Will Earth be gone in our lifetime? What about the moon? Who knows? All we know is that space is more extraordinary than we ever could have imagined. Now, you might think that 100 light years is extremely far, but keep in mind that the center of our Milky Way is only 100,000 light years away from Earth. And that makes this planet extremely close by comparison. Scientists believe that this planet is 7 times the size of Jupiter. There's a team of scientists in NASA researching this planet, hoping they can find more information. They think that this is a relatively young planet, but don't know how old it is yet. How was this planet kicked out of its solar system? What could have caused it? How many others are like it? Did any of these orphan planets ever hold life? Who can say? But with all this information, scientists wonder if this is not the phenomenon, but we are. Thank you.
Thank you so much, Isis. That was a great presentation. All right, I am very excited to turn it over now to, one second, our amateur astronomer, Kristen Testin.
How's that for audio? Is that better?
Can everyone hear her okay? Go ahead and, yep, looks good.
There's a little delay. So what I'm going to be doing today is, you saw that little icon. That's called stellarium. So I'm going to share out my screen here. So stellarium is right here, stellarium.org. It's a platform for many different things, including the web. And it acts like a mini planetarium. You can see all the features it has, but what I want to show you is what the sky looks like tonight and into the future. I'll switch to my other monitor. Can you see that screen?
Yes, we can.
Okay. So this is the stellarium loaded up. And we have controls down here on the bottom. I've got it in full screen version, set for exactly to date and time. And since I'm in Omaha, I put my area. This will work for most of Nebraska, however. Change directions. Traditionally, we look south because there's lots of cool things to see in the south. We're going to fast forward time a little bit, let the sun set. A little bit further. So we're looking south. This is kind of the night sky. I did alter it a little bit so you don't see all the stars. As a review, we talked about some of the planets. So here's Mercury. As it gets dark, it's going to be pretty low in the sky. One thing you can do, if you're not sure what you want to find, you can open up the search window and search for Mercury. And we're going to fly into it. Because Mercury is a planet closer to us than the sun, it actually goes through phases. So if you had a telescope and you were able to see in the direction of Mercury, this is what it would look like. I'll pause our time. Mercury is a possible planet you could see this evening, looking to the southwest. Now, in the last couple of months, we have been viewing Jupiter and Saturn. However, they're passing behind the sun right now for this end of the month, so we don't want to go looking for them. Neptune is visible. Neptune, you do need a telescope to go out and see. What I like to do before I go out and observe is I like to go onto my stellarium and find out what kind of things I can see. So as a beginning astronomer, I might want to put on constellation lines. And of course, I don't know their names, so I want their name lists. And sometimes I like to put on the pictures.
That is so
a lot
cool.
of times the pictures really help connect it to my mind. If we took off the pictures, some of these, like, I don't know if that really looks like a fish to me. Aries does not look like a ram. But yet, in mythology, that's exactly what it is. It's a sheep. We're in the season of winter. So what we're going to see rising in the southeast, so as the sun is setting in the southwest, we're going to find our constellation of Orion. And some of the cool things in Orion. First of all, you'll look for 3 stars that line up to make the melt. Then we have a shoulder called Betelgeuse. And his other shoulder here is Bellatrix. And then we have Rigel down here.
Is that Bellatrix, like the same spelling? Oh, I was going to say from Harry Potter, wasn't it?
Yes.
Okay.
A lot of times you'll see a lot of these names familiar in either reading your science fiction or in science in other ways. A lot of Harry Potter references will come to you in the sky from Orion's belt. If you go to the left or more to the east where objects are rising, you'll find the brightest star we see in our night sky called Sirius. Harry Potter reference.
Another one, yes.
Guess what? If we put our pictures on, Sirius is a dog. It's the dog star in the dog constellation. Just like in Harry Potter. Turns into a dog. But the constellation of Orion here, use your imagination, you could probably turn it into a person. Shoulder, shoulder is belt stars, foot, foot, and lots of cultures, different cultures saw it as a person. So one cool thing about Stellarium is you can identify different cultures. So what I did was went into the sky view option. There's a tab called Star Floor, and there's all these different cultures. So you can see what the Ojibwe saw as constellations in the sky. They saw it as a person too.
Wow.
We could switch it to Egyptian. Some of them have more artwork than others. So, another person here. A little bit different than what you would think of as Orion. We're going to go back to our traditional Western sky. What the scientists use. There's a couple of different versions of the Western sky here. There's the Sky and Telescope version, traditional. One of my favorite things, besides for finding bright Betelgeuse, which is orangish red in appearance. Zooming in. Those look orangish red. There's his belt stars. If you go down his belt, he carries a sword. Between the last couple of stars and the sword is the Orion Nebula. And they insert Hubble images. And so if you had a really big fancy telescope, you may see these clouds as bluish purple. With some processing and development, you can get a little bit more of the coloration. Another one of these cool images from Orion's belt. If you go to the right, like connect the dots, you run into another orangish star. This one's called Aldebaran. It is the brightest star in Taurus the Bull. So along with clicking into it, you can find a little bit more information. These are images and locations, and you can adjust what kind of content you want to read. And there's our moon. We extend the horns of Taurus the Bull. There is a remnant of a supernova. Oh, I forgot it. Wow. We'll come back if I remember the name. In our Betelgeuse sky, we went to the orange star Aldebaran. If you keep going off in this area, you're going to find another orange object that appears exceptionally bright. That's the planet Mars. So we can zoom in on Mars. As we learned from our presentation today, Mars can appear red. That's why it was named after the god of war. In reality, our images showed it more of an orangish brown. So our atmosphere really makes it look more red than it is actually. So
Is it the Crab Nebula?
there's Mars. Yeah, that's what I was thinking. Thanks.
You're welcome.
Crab Nebula is in the horns of Taurus. Let's see if we can put that in. And of course, there's lots of variations on the name depending on what catalog you look. So, Crab Nebula is the common name for it. It's very close to our moon tonight. There's the NASA image. So this is a composite image. So it has both visual in your telescopes. You might be able to see some fuzzy gray. This also has some X-ray, which is some of the red stuff that we see. Stellarium can also act like a telescope. So if you know what kind of telescope you have, or your eyepieces, you can actually use these buttons up here. That's what our moon looks like tonight.
Will you show those, what did you call them on the moon?
Oh, the rays?
Yes, will you show the rays?
Okay. So some of my favorites are a little bit off. Right. You can see right here how it looks like a big splat. Those are the rays from impact craters. Here's an ancient one. You can see where so a lot of these lines are actually dirt rays.
Okay, cool.
From impacts. So all these circles are impacts from asteroids, meteors. Some of them, depending on the speed and the size of their impact, they make little mountains in the center. Oh, that's my little. Sometimes you see these little dots floating around. I can put on satellites or meteor showers, and we can see those flying by. This dark area was filled in by liquid rock. So the inside of the moon at one time was liquid, and with the large impacts, it cracked the surface. Liquid rock came out, cooled and hardened to make these lava plateaus called Mari or Maria. I mentioned satellites and meteorites. So there's a button down here to show meteor showers. So we had a presentation. Some of these that they're showing are ones that you wouldn't see with your eye. They might be things that a radio telescope would observe or a high-powered telescope. Things that you might not see on a regular basis. The other thing I like to show off is satellites. That's the catalog of meteor showers. So if there was like the ISS coming by, we could see that in the orbital path.
Can you show us the Milky Way?
We can see the Milky Way right here in our picture. One of the adjustments I will do is alter our sky a little bit. So I can change the light pollution index. So I'm going to drop it down to 1. And I can also take off the limiting magnitude. So your eyes are only strong enough to see down to like a magnitude 7 in really dark skies. So it's set at 6.5 here. So if you take that off, you're going to see even more stars.
Hmm.
So you can kind of see the band of the Milky Way right here.
Yeah.
The gas and dust.
Do we want to see if any of our Facebook viewers would like us to find something?
Absolutely.
All right, if you're watching on Facebook, feel free to type in the comments and we will find it for you.
I'll attempt to find it.
Well, we will do our
It's not
best.
visible in our sky. It's located in the southern hemisphere. And we can take off our atmosphere and our planet surfaces in order to do that too.
Okay.
So there's our atmosphere.
Oh,
There's taking away our atmosphere. Taking away our ground.
interesting.
We can also change for any date and time in the future. So if you want to know what it would look like on your birthday, you can do that. You can observe how, turning to the south again, how the sky changes throughout a month. There's the 25th, 26th.
So Ashley wants to see Saturn's rings.
Okay. Search window. I got them now. Saturn right now, as you can see, is really close to the sun. So these aren't ones you want to go out and look for right now. Saturn just switched over to the morning sky. We talked about Titan, its largest moon. It does have an atmosphere like Earth. You can see there's 4 of Saturn's rings, or not rings, but moons, but you can see with a pair of binoculars. Io, Europa, Ganymede, and Callisto. Zoom in really close. Now these are just flat images. This dark space right here is called the Cassini division. There are some moons that are clearing out the little dust trail, leaving it a void. There's also rippling that occur in the rings that you don't usually see in the pictures. These are some of Saturn's moons, Mimas, Dione.
I was surprised to see how far Titan, like how far away Titan is.
Yeah. And part of it is just where it is in its orbit, too.
Okay.
So as it passes in front or behind Saturn, it can appear to be really, really close, too.
Is that accurate?
The image, the way they have it in here, yes.
Okay. So Isis just said, fun fact about Saturn, we are seeing what it looked like 500 years ago.
Not quite 500 years, because it's not 500 light years away.
Okay.
But that might be more like 500 minutes.
Oh, okay.
Pluto. Absolutely. And I missed a couple in there. And as we know now, Pluto is still classified as a dwarf planet. Sometimes, like most people's telescopes, you wouldn't be able to see Pluto. You need a NASA type telescope. Satellite images is where we get most of Pluto. But you can see Pluto, and most people pronounce this as Charon or Chiron. There's Nix, Styx, Hydra, and Kerberos. So at first we just knew about these two. Karen and Sharon is just about 2/3 the size of Pluto, I guess. Don't have those facts memories, but they orbit each other. So you're right, it's like a sister planet. That was earlier in the presentation.
Mm-hmm.
That's as close as we can zoom in for the sun. I've got lots of requests for lots of different things.
I see that.
This software is free. It is open source, so anyone can use it. And a lot of times your planetariums would be using it to deliver their show. Jupiter. All moons that you can see. Is it fabulous? And currently we are not seeing a great red spot. So I set it to today's time. And I noticed how it rotated a little bit.
Mm-hmm.
So it's all the perspective from Earth. As Earth moves, Jupiter's also moving. We're all moving at different speeds, slightly different angles. So you may get different twists on the planets. There's February, March, April. Looks like it's getting closer to us. May, June. So June 24th, you can see the red spot at this current time.
Nice.
October 24th, red spot's visible this time. Someone said they wanted to see Cassiopeia. Cassiopeia is a constellation in the north. Zoom back out. We'll put our land back on. There's our atmosphere. This is for current date and time. So we're going to jump a couple hours. Let's not do October, let's do January. So if you wanted to plan a star party and have a list of what you want to see, you can use this software. Pick out that. So our moon high up at
7:30.
7:30. How I find Cassiopeia, the easiest thing for me is to find the Big Dipper, which is part of Ursa Major. Four stars make a cup, 3 stars make a handle.
Mm-hmm.
In the winter, in our evening sky, it's going to be standing on its tail. Every season, our bear starts in a new position. Use the sippy end of our cup, which is the waist of our bear. Those are the pointer stars that will take you to Polaris, our North Star. You keep going and bend just a little bit, then you're going to find the M or W in the sky. That is Queen Cassiopeia. So we put on our pictures. One way to view her is she's sitting there. Oftentimes you will see her holding like a mirror. She is the vain queen. The Big Dipper is not an official constellation. It's part of a larger constellation called Ursa Major. Ursa is Latin for bear. Major means big or great. 1, 2, 3, 4. 1, 2, and then the third one's kind of hiding in the tree.
There it is.
1, 2, 3. I just waited an hour. Pointer stars, North Star. Keep going, bend just a little bit. I did cut our light pollution out, so that's why you see so many stars. If you're in an urban setting, change your light pollution. And as Girl Scouts, you may want to join some citizen scientist project. The project is called Globe at Night, and a lot of Girl Scouts across the world are participants. And you put in your location and you observe the night sky and indicate what your view looks like compared to pictures. And it'll give you a light pollution number. And that is going into a worldwide study on light pollution. A Big Dipper, pointer stars, North Star, and in the winter months, how it looks more like an M versus a W. That is Queen Cassiopeia. I know there was others I missed. What else did you want me to show you, Kat?
Do we have any more requests from Facebook?
What's the app called? Stellarium. That will be in our credits also.
Mm-hmm. And we already talked about Ursa Minor.
Capricornus. So Becca from our troop wanted to see Capricornus. Capricornus for us is a little bit harder. That's just because of where it's located in the sky. Easier to see closer to the equator. It does come out and peak a little bit. Constellation of Jupiter. Or sorry, the planet Jupiter is in the constellation. The Sun, Saturn are all in the constellation of Capricornus right now. If you like studying your zodiacs, you might be going, that's a little bit off for my birthday. Well, that's because those zodiacs and your horoscopes originated a long, long time. And since then, we've moved within the galaxy. We also have an orbit that tilts and wobbles a little bit. We've wobbled about one constellation.
So are you saying that if you
read your horoscope as Capricornus, that means you have a late December, early January birthday.
Right.
However, you're not in the constellation Capricornus until late January.
So we've all shifted, is what you're saying?
Yep. So the beginning of January, you're technically a Sagittarius.
Interesting.
So if you want to know your sun sign, which is your zodiac horoscope, you have to look at where the sun was on the day you were born. And for most people, it's one sun sign to the
back.
right.
Yeah.
Back,
yeah. Interesting.
That's early February.
So, and you said this app is free.
It is free. It's open source, so you can do lots of different things with it.
Is it Stellarium Plus or just Stellarium?
I go with stellarium.org, and it then gives you everything. If you're looking on like a smart device, like an iPad or your phone, it might be called Stellarium Plus. I do not know.
Okay.
Oh, I see a question. What is the zodiac?
Yes.
Okay, that's a great question. Ooh, oh, that's grass.
That's some nice looking grass. We could use that in Nebraska.
I could change it. There are different settings for your ground.
Oh.
Default that's closest to Nebraska. So the zodiac constellations are the constellations that the sun passes through within the year.
It
so
says
the sun is right now in Capricorn.
Mm-hmm.
Next month, it's in Aquarius. Month after, it's in Pisces the fish. And then Aries the ram.
Mm-hmm.
Taurus the bull.
Mm-hmm.
So that's in May. About 6 months. This is what we're seeing in our night sky currently. We go to Gemini the twins. Then another favorite of mine, Cancer the crab. Let me get rid of my atmosphere and show you why. That is a crab.
Yeah, it does look like a crab, doesn't it?
If you say so. I see an upside down Y.
There was another leg.
Yeah. In Omaha, I don't see that really faint star.
Oh, I see.
And then from Cancer is Leo the lion.
Mm-hmm.
These are where the planets are July 24th of this year. We'll have Venus, Mars, and Rigel. We had this similar in December, but instead of Venus and Mars, it was Jupiter and Saturn, and that was your conjunction.
Yeah, the Great Conjunction.
And the Christmas star, because it was next to Rigel, which is King Star. Leo the Lion's King of the Gentle. And it's supposed to tie in with the Christian holiday of the birth of Jesus.
So then after Leo is Virgo.
Yes. And then Libra. So these are scales right here.
Mm-hmm.
Another hard one for us to see.
Yeah.
With city pollution. From there, we have
Scorpio. Yeah.
So this is July, August. You'll see this high in the sky. Then we go to Sagittarius.
Mm-hmm.
So as a beginning astronomer, to learn the night sky, one of the first things I did was learn the zodiac constellations, along with the ones in the north that are called circumpolar.
What does that mean, circumpolar?
They circle the pole.
Oh.
So living in the northern hemisphere, there are 5 constellations that never set for us. The Big Bear,
Mm-hmm.
Ursa Major, Ursa Minor, the Little Beaver, Queen Cassiopeia. Her husband, King Cebes. I think he looks like a house. And those are the major ones. There's also Draco, the dragon. He's a little bit harder to find. The biggest constellation, there is a huge serpent. Hydra, right here. It's really big. There's another really big one that they've actually split up. And that's one we don't see a lot. The ship Argos.
Is there a peacock? Do I see peacock feathers?
Yes.
Interesting.
I can't find Argos. But yes, the southern hemisphere has more modern constellations. You're going to see some more instruments. And some unique animals. So there's a peacock. There's a bee. Centaurus is an official constellation. Sagittarius, yes, is a half man, half horse, but there is the centaur. They've got a clock, cranes. Creature is often seen as this chalice. Sextant, which is an instrument for navigation, looking at angles.
Well, we have about 12 minutes left, so I'm thinking we
There's
should.
the ship.
Oh wow, there it is.
So it's the front, back, and sails. They kind of split it up. You see a little bit of it, and then on the hemisphere. What else am I missing?
I think that's a great overview.
It's just something you can start playing around with. As we started, our sun is starting to set. Venus is a little bit out in front. Mercury's a little bit behind. Our moon is visible in the sky. Information you can get includes magnitude. That's how bright it appears. The more negative, the brighter it is. This is RA is right ascension. DEC is declination. So that would equate to Earth's latitude and longitude. So that's our sky map. We use right ascension and declination. So right ascension is given in hours, minutes, seconds. Declination is degrees. That's above or below the equator. We would extend our equator out into space.
Awesome. Well, we should probably move on to the rest of our PowerPoints.
Okay. I know yesterday we had the International Space Search. I don't have that loaded on yet. So we can find satellite trails too. I'll stop sharing my screen. And you can switch over to your video.
All right. So for more information, you can always go to nasa.gov. They have a lot of information about space, and if you want to monitor solar winds, you can go to that website right there. There are also live transmissions from the International Space Station on upcoming spacewalks. You can even do a Mission to Mars Student Challenge that is going on right now. So if you're interested in that, you can go to that website there. You can also spot the station, meaning the International Space Station. A lot of people will go to that website and say, hey, I saw it tonight or at this time. And if you're interested in anything that's going on in the sky, you can always go to timeanddate.com/astronomy/sites2see.html. And that will give you a list of what's happening in the night sky. Do we have any last minute questions about our presentation tonight from Facebook? All right, if you do have questions, please feel free to put them in the chat and we will get back to you at some point in the next few days. Thank you for joining us and we hope you enjoyed our presentation. Have a wonderful day. Bye, everyone.